All right, let's talk about something that drives every single person in test automation absolutely crazy. You write the perfect script, the logic is flawless, and yet your tests fail randomly. Well, today we're going to hunt down and solve the #1 cause of flaky tests, synchronization. Let's get into it.
Here's the game plan. First, we're going to really understand the problem itself. Then, we'll look at the biggest mistake everyone makes when they first try to fix it. After that, we'll dive into Selenium's 2 powerful solutions, and then wrap it all up with a clear strategy you can use today.
You know the feeling, right? You've double-checked your locators, your logic is airtight, everything looks good to go. But you run it and it fails. So what is going on? I'll give you a hint. The problem isn't in your code. It's all about the timing.
Okay, let's pull back the curtain and meet the real villain of this story. It's called the synchronization problem, and it's the secret reason why your tests are so unpredictable.
So what is it really? Well, at its core, it's just a simple race condition. Your script is running at lightning speed, firing off commands, but the web application, it's still trying to catch up and load everything. Your script is ready to go, but the web page just isn't there yet.
And love this analogy. Think of your script as a world-class sprinter, just exploding out of the starting blocks. The web app, on the other hand, is more like a marathon runner. It's got to take its time, load all its assets, run JavaScript. It's a long process. The sprinter gets to the finish line and is wondering where everyone is because the marathon runner is still miles behind.
And the result of this race? Boom. You get that dreaded, infamous, no such element exception. But here's the most important thing to understand. That error message is basically lying to you. The element isn't actually missing. Your script was just too early. It showed up to the party before the host even had a chance to open the door.
So the obvious fix is to just tell our script to slow down, right? To just wait a bit. Well, let's look at this really common first instinct and see why it's actually the wrong way to solve the problem. Almost everyone's first attempt is to use thread.sleep. And it's important to note, this isn't even a Selenium thing. This is a command from Java itself, and it's what we call a hard pause. It is a blunt instrument that just freezes your script dead in its tracks for a set amount of time. And hey, it seems like it works at first. But here's why it's such a bad idea. Let's say you tell it to sleep for 5 seconds, but the element actually shows up in just 1 second. You've just wasted 4 seconds for nothing. Now multiply that waste across a huge test suite, and your execution time goes through the roof. And even worse, what if the network is slow one day and the element takes 6 seconds? Your test still fails. It's just inefficient, it's unreliable, and it makes your code a mess. We have to do better. So if that hard pause is the wrong tool for the job, what's the right one? Well, let's meet Selenium's first real solution, the implicit wait. I want you to think of this as your global safety net. The difference is night and day. A hard wait is, well, it's dumb. It waits for the full 5 seconds you told it to, period. But a smart wait is intelligent. You give it a maximum timeout, say 5 seconds. But the very instant that element appears, it continues. If that takes 1 second, it moves on. No wasted time.
You know, the best part is how incredibly simple it is. You just set it one single time right at the beginning of your script, and that's it. From that moment on, it automatically applies to every find element command you run. It is the definition of set it and forget it, and it will solve the huge majority of your timing issues without you lifting another finger.
Okay, but what about those really tricky elements? You know, the ones that are super dynamic, or they fade in or become clickable after a process? For those, a safety net isn't quite enough. We need to get more precise. We need to pull out the sniper rifle, the explicit wait. Now, this is a really important shift in thinking. The implicit wait, our safety net, only ever asks one question. Is the element there yet? That's it. But an explicit wait is so much more powerful. It doesn't just wait for time to pass, it waits for a specific condition to become true.
Now, it might sound complicated, but it's really just 2 simple steps. First, you create this thing called a WebDriver wait object, and you give it a max timeout.
Then, when you get to that one problematic element, you just tell that object to wait until whatever condition you want is met.
So what kind of conditions are we talking about? All kinds of incredibly useful stuff. You can wait until an element is not just visible, but actually clickable. You can wait for an alert box to pop up. You can wait until a piece of text appears inside an element. This is the kind of precision control you need for modern dynamic websites.
And it's worth a quick shout out to something called a fluent wait. Just think of it as a supercharged explicit wait. It lets you control even more, like how often Selenium should check for your condition. It's an advanced tool for those really tricky front-end frameworks.
Okay, wow, we've covered a lot of ground. We've talked about the hard pause, the safety net, and the sniper rifle. So now, let's put it all together and build a really robust, professional waiting strategy.
Let's just break it down plain and simple. Thread.sleep, when do you use it? Never. Seriously, it's a debugging tool at best, not a real solution. Implicit wait? You use this always. It should be the first line in every single test script you write. It's your default safety net. And the explicit wait? This is your specialist. You call it in when you have a known problem element that needs something more than just being present, like a button that only becomes active after an animation finishes.
So what's the ultimate secret? The real best practice? It's not about choosing one or the other. It's about combining them. You always start with that global implicit wait to catch 90% of the problems automatically. And then, for that last tricky 10%, you bring in a targeted, precise, explicit wait to handle that specific case. That combination is what gives you tests that are both fast and rock-solid stable.
So, there you have it. You now have the tools and the strategy to finally put an end to flaky tests. The only question left is, what's that one frustrating, unreliable element that you are going to go and fix right now? Thanks for watching The Explainer.